Hello everyone, welcome back to this online class. Today we are going to look at numerical solution of ordinary differential equations, and in particular we are going to look at Euler's method. So we have this question. We are asked to use Euler's method to solve the initial value problem given by dy over dx is equals to 2x plus y, subject to the initial condition, that is y of 0 is equals to 1. Use a step size of h is equals to 0.1. Estimate the values of y of 0.1 and y of 0.2, correct to 4 decimal places. So let's see how to go about this problem. If you look at our ODE and the initial condition, this 2x plus y is our f of xy. Here, the 0 is our x naught, and the 1 here is our y naught. I said this is f of x, y. So we can say that our x naught is 0, our y naught is equals to 1, and our f of xy is equals to 2x plus y. Remember the iterative formula used in Euler's method is that yn plus 1 is equals to yn plus h times f of xn, comma, yn. This is what you are calling Euler's method, where n ranges from 0, 1, 2, 3, all the way up to infinity. So you can write here where n is equals to 0, 1, 2, 3, etc. So the derivation of this formula, you can find it in my PDF notes. Spend some time so that you look at how that formula is derived. Now, look at our f of xy. It is 2x plus y. We need f of x and yn. So from here, it means that f of xn, yn is equals to 2 times xn plus yn. So I replace it back into this formula and say that therefore yn plus 1 is equals to yn plus h times 2xn plus yn. And so that's our iterative formula for this particular problem. We know h to be 0.1. We know our x naught and y naught. So let's put n is equals to 0 and see what you're going to get. Put n is equals to 0. That will give us y1. y1 is equals to y naught plus h times 2x naught plus y naught. And we know these values. Our y naught is 1, h is 0.1, 2 times our x naught is 0, y naught is 1. When you press this in your calculator, you're going to get 1.1. 1.1. Let me illustrate what we mean by y naught, y1. You see, what we have is this one. Our initial condition, we are told that when x is 0, y is 1. So, and our step size is 0.1. So, you go to 0.1, then 0.2, etc. Because we want to find the value of y when x is 0.2. So, this 0 is x0, this is x1, and this is x2. This one is y0. I don't know the value here. That is y1. Neither do I know the value here, which is y2. So when we talk of y1, is the value of y when x is 0.1. So you can say that here that therefore y at 0.1, which we are saying is y1, is the same as 1.1. So we have found this value here already. Now we need to find the value of y2, which is y when x is 0.2. So let me bracket this. Now for you to find y2, you now need to substitute n is equals to 1 in this iterative formula. So you can write put n is equals to 1. Now what are you going to get? You're going to get y2 is equals to y1 plus h into 2x1 plus y1. Replace y1 is 1.1, h is 0.1, 2 times x1. x1 is 0.1 plus y1, which is 1.1. When you press this in your calculator, you need to get y2 is equals to 1.23. 1.23. So that's the value of y2. And so what does it mean? That y at 0.2 is equals to 1.23. So you can say here that therefore y at 0.2 is equals to 1.23. It is the value of y2. Again, I'll bracket this. And so if we look at our question, we have answered what you are required to find. So this is how to use Euler's method to solve initial value problem. So thank you all for watching this video. Please subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we'll look at more problems involving numerical solution of ODEs. Bye-bye.